So the real numbers. What I want you to write down, the real numbers is the set of numbers containing rational and irrational. And that's what we're going to focus on today. What's the difference between rational and irrational? And then within the rationals, we have some subsets. So how many of you heard of the words irrational and rational in terms of math? We've heard those words before? Okay, so we're going to start talking about the irrational numbers first. Does anybody maybe like remember what an irrational number is? Decimals that?
Where that came out of the bar?
No.
Is it rational? Rational?
Ah, decimals that don't end. Okay, and have no repetition. What number are you referring to there, Katem? Pi. The number pi is an example of an irrational number. 3.1415, blah, 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 blah. It just keeps going and going and going and going. There's no pattern. There's no repetition. It's just a never-ending decimal.
You have ear problems?
You do. Take them out. Okay. All right, what's another example? So like, what if I put the square root of 7 in my calculator? Am I going to get a nice number?
No.
No, because 7 is not a perfect square. If we had the square root of 9, that would equal 3. But the square root of 7 is going to equal a decimal that doesn't end and doesn't repeat. Okay, so give me another example of an irrational number using a square root. Square root of 5 would be good. Okay, square root of 4 would not be a good example.
Plus 2.
Yes. Okay. Okay. Now, separately, we have rational numbers. Rational numbers, in its truest definition, are fractions or numbers that can be written as a fraction. So if we can write a number as A over B, boom, we have a rational number. Now, not all the time do we see a rational number written as a fraction. So not all the time do we see our rational numbers written as a fraction. So like, what if they're written as a decimal? Well, basically, if it's not irrational, it's going to be irrational. So these decimals, they end, okay? Or they have repetition. Okay, it's going to be one or the other. So examples of rational numbers. So anything that's a fraction. 2/3 is a great fraction. Okay. A decimal that ends 1.75. That is a rational number. True. What about the number 0.3333333? So that is a decimal that repeats. That hat, remember, that's our repeat. Okay. What about a number like -4? Is that rational?
Yes.
It is. Okay. I mean, it doesn't look like a fraction, but we can write it as a fraction, -4/1. What do you mean by normal number? Okay, so Kadam, let's go to that. All right, so Kadam's asking about normal numbers, 1, 2, 3, 4, 5, 6, 7, blah, 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 blah. So we're not gonna call those normal numbers, we're gonna call them natural numbers, okay? Within our realm of rational numbers, we have some subcategories, okay? When you learned to count, where did you start counting at?
0.
So when you were 2 years old, you started counting 0, 1. No,
Yes.
you did not start counting at 0. Okay, if there's like a bunch of objects and you're counting them, what number do you start at? You start at 1. It's natural for us to start counting at 1, 2, 3, 4, 5. Those are what we call natural numbers. I want you to write that down. Okay.
Everything must be with an actual.
So counting numbers are natural numbers. So 1, 2, and so on. Has to be positive. Okay. Now, natural numbers, or excuse me, whole numbers are all of the natural numbers, but we are going to put one more number in front. What number goes in front of it? 0. 0 is when we are in the natural, or excuse me, the whole numbers. The word whole has a hole in it. 0 has a hole in it. I'm trying to help you remember it. Number. Okay, integers. I'm gonna add to this list now. What?
Negative.
Negatives. So yes, there's 0, 1, 2, 3, 4, 5, blah, 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 blah. But then there's also going to be all of the negative numbers. So basically all the numbers we would use to like label our number line, those are integers.
Positive.
Positive, negative. But if I have like -3.5, that's just a rational number. We can't put that in any of those categories. Correct. Okay. So what we need to be able to do is determine, hey, here's a number, where does it fit? Well, I told you we have 2 categories, right? I told you we have irrational numbers. And I told you we have rational numbers. Okay. Well, within our rational numbers, we have integers. And then if we take off the negatives, we have whole numbers. And then if we take off the 0, we have natural. So go ahead and label these, and I'm going to talk through this a couple times.
I know, because I'm bored. Literally, I think you lost 4 matches.
Okay. Yeah. TV. For real. That like surprise you? Like I don't look like I could be a basketball coach?
Yeah, you do, that's why I.
Thank you. Okay. All right. So here we go. Irrational numbers. Numbers get thrown over there. That's pretty straightforward. But our rational numbers, okay? If we have a natural number, notice how our natural number is inside of our whole numbers, which is inside of our integers, which is inside of our rational. So if something is a natural number, it's also a whole number, which is also an integer, which is a rational number.
So if you put
Yes. So like, give me an example of a natural number. 4. 4 would be a natural number, but it's also a whole number and an integer and a rational. Okay.
But you don't have to write it in it.
No. So like -3 is an integer. Well, we know it's an integer, so it's also a rational number.
Yeah.
Okay. Now, I also have these buckets up here to help give you a different visual. Okay, so this is one visual. I'm also going to use this visual. So like, I can't make muffins or pancakes. I hope my kids aren't upset. Because these are all of my cooking bowls. Okay, if I have a natural number, do you see how it sits inside of all of these buckets? Okay, my natural numbers fit inside whole, integers, and rational.
You should have pieces.
Yeah, why?
But they don't fit.
What'd you say?
Why didn't you bring like baking supplies?
Because I'm not
We're not baking
teaching you
anything.
about baking.
This is not FCO.
Okay.
This is.
Okay, so go to the next page. We are going to classify all of these numbers, okay?
But is that the greatest value sign? Greatest value is wrong.
That is the absolute value. You're close. Okay? All right, so -47. So first of all, I want to know, does it live in rational or irrational?
Irrational.
Why?
Okay, irrational would be decimals that go on forever and never repeat. Is that this? No. It's gonna be somewhere in the rational category, okay? Well, -47, is that one of our like counting numbers?
No.
No. Whole numbers is 0, 1, 2, 3.
No, doesn't. Oh, sure, it goes in the integer.
Since it's a negative number that is like, there's no like fraction or decimal with it, it's gonna be an integer. Well, my integer bowl is also in the rational bowl. So we are going to write, it's an integer and it's rational. The next page. Do you see it? Okay.
Hey, Dave.
Yeah.
You have to be clear.
Okay. Our next example is 2 3/8.
I can't see you. I can write that down.
Oh, what?
Big.
Send you back, huh?
What?
Okay, so this is a fraction.
It goes into the one by itself.
So what one by itself? Rational or irrational?
The irrational.
But irrational.
Okay, I know what this is.
Okay. I want you to go to the previous page and find the word fraction. Where does it say the word fraction?
In the rational.
In the rational. The very definition of rational is when we have a fraction. We have a fraction. This is going to be in the rational bucket. Gosh, take a deep breath. Okay.
So everything is a fraction.
Not Not everything. Hey, just, that's why I need you to be patient, okay? Cash asked me about this symbol right here, and we decided this means absolute value. Emma, what is the absolute value of -9? It's 9, okay? So we need to decide where 9 goes.
It's not accounting because it has a -9 when it shows.
Hold on, but when I simplify this, because we gotta simplify our numbers, okay? When we simplify it, it's a +9.
Oh, so just natural.
So that is a part of our counting numbers, our natural numbers. Hey, Austin, I really need you to pay attention.
I am.
Okay. You can't pay attention and talk.
And I was
Okay.
just talking.
So it is a natural number, and if it's a natural number, it is nested in all 4 of these bowls. So we are gonna write, it is a natural number, which is inside of the whole numbers, which is inside of the integers, which is inside of the rational. Okay, since it's in this cute little bowl, it's in all of them. Join the party. Me?
I need your brain. When if you have a break today, we can see.
I will, yeah, probably 8th period.
Okay.
We're a little heavy in our rational numbers here.
I believe in you. That would be a part of my.
Okay, so let's talk about square root of 23.
It doesn't have a square root, nor is it repeated.
Okay, so 23, is that a perfect square?
No.
No.
No, so the square root of 23 is gonna be an ugly number. Ugly number.
That's so good.
It is going to be an irrational number, okay? Anything, if you have a square root, if the number underneath of it is not a perfect square, it's gonna be irrational, okay? All right. 1.5625.
Irrational.
Why?
Because it's never repeating. It's not a
Ha-
Oh shoot. No, that's
Does it end?
Yes.
Does it end or does it keep going?
It ends.
It ends.
So it's rational.
If it kept going, there would be like a dot, dot, dot. It stops at this 5. Okay, so since we have a decimal that stops,
It's irrational.
it is rational.
And it's just rational.
Just rational because it has the decimal attached to it. Austin, this is your last warning.
I wasn't talking.
Austin, I literally heard your voice. So unless you can make noise without talking and that it sounds like words.
Yeah.
Yeah, okay. That's a pretty impressive skill.
Stop talking. She was talking.
This is your last warning.
She was talking.
This is your last warning. All right, number 6, 0.
It's rational.
It is our rational bucket, but specifically, look at your list. Where does 0 first appear? Whole numbers, because there's a hole in 0. Okay, so I forget the natural numbers. He doesn't like 0. 0 is a whole number, but our whole number bucket is inside of the integer bucket, which is a part of our rational bucket. So we have to list all 3. Emma. Okay. Then cash you back. Okay. Negative square root of 64. Ah, it's a square root. It must be irrational.
Yeah, it's irrational.
What's the square root of 64?
64. 8.
8. So negative square root of 64 is -8. So Tony, -8, where do we put -8? I like it, use your resources. Go back to the previous page. Where do we put negative numbers that don't have fractions or decimals?
Oh, they're integers.
Yes, Tony, we have integers. And in our integer bucket, it sits inside of rational. Okay, number 8, we have a decimal. What does that line mean?
No, repeat it.
1, 2, so it's -0.123, 1, 2, 3, 1, 2, 3, 1, 2, 3.
Irrational.
Do a waltz here, Tatum.
Is it my bubble?
Right? 1, 2, 3, 1, 2, 3. What are you doing?
I'm just asking random questions.
So Emma, where would we put this one?
In the irrational,
Why?
because it's never ending numbers.
But, okay, so it's true, it never ends, but it's repetitive.
So it's never ending still.
But if there's repetition with our never ending, then we put it in the rational because we could write it as a fraction.
I'm not doing this anymore.
I'm sorry that you're frustrated, but it might help if you focus. Okay. All right, we have 2 more before I ask you to do a couple.
That's for me, because I'm trying to go home.
You have a date today, you're not going.
It's just for me because I don't want to go home.
30.
30. Do you hear him? Don't
Tony,
you even think
God,
about
I
that.
have to do it today.
Okay, -24/6. Fraction, rational, done, right? Can is -24/6 something that we can rewrite?
I'm thinking.
What's 24 divided by 6? 4. It would be 4. So really, we need to figure out where -4 belongs.
By itself.
Not by itself.
So then I'm negative 4.
So -4, yes, would belong in our integer bucket. Okay, and our integer bucket also belongs in our rational bucket. Okay. All right, and then our last one is the cube root of 8. Oh, it's a radical. It must be irrational, right?
No.
No, because Austin, what is the cube root of 8?
Wait, 2?
Yes, 2. And Austin, where does 2 belong? Austin's gonna get it. Are you ready?
Hold numbers.
Integers.
You have 2 very kind humans sitting across from you. Okay? 2 is it's one of our counting numbers. It's natural to count with. Okay? So since it's a natural number, it fits inside of our whole numbers, which fits inside of our, this is kind of annoying, right? Integers, which fits inside of our rational.
Miss, we gotta write all that down all the time.
On a problem like that, yeah. But look at down below. Here, I'm asking you to put it in the chart. So like, let's look at letter C. Letter C is 8. 8 is what kind of a number? 8 is a natural number. So I'm gonna put C right here because it's a natural number. So if it's here, then it's also in the whole, also in the integer, also in the rational. You and your elbow partner, I'm going to give you 2 minutes to place all of these, but don't do K or M. Go ahead and cross those out. Okay.
I just like
I did say when touch that, but I need the hustle.
actually this
Okay. Hey.
We have 8 minutes.
So he said that this is a rational, and that's also an integer. Very natural. Rational.
Okay, so like here,
Feel like we got that.
you see this one?
That's too good. Too good.
At that hospitality, he was like,
I was only there for Tatum.
you wanted that. Wait, that's the yellow one, bro.
I know, it's the last day of the first one.
Oh, wait.
The new one starts tomorrow.
Oh. I didn't even think about that.
Bro.
You the program. Are you lost? You use Chris now. But you use the second. Are you lost?
Hey, 1 more minute, all 8 of those problems.
You think I'm not gonna be on my phone? You know?
Let me just like do this to the goal. Wait, I'm actually going to.
I tried. Really tried. Dang, you suck. Ah! You said you suck. Oh, okay, you made that one. You made that one.
All I see is 0.36
I'm already done.
I'm already done.
Man, I swear to God, put that on me yet.
Wait,
Maybe she didn't have to run.
Miss.
Oh!
Oh, this is what he's doing.
Okay.
You were like, ah,
Go.
no! I'm stuck. Oh, that one. I'm up. Okay.
I thought I had been here 2 years.
Grab it. Grab it.
I don't even know. All I got was that one and that one.
Sophia, what would? Never mind. Yeah, he's in this. Why do you look so mad?
Why so mad?
Why is he on
Okay.
What is he gonna do?
You know,
What if it's-
I said, shut up.
yeah, like how many times did you play that wrong?
Shut up.
Up a little bit. Okay, square root of -50. Is 50 a perfect square? So when we take the square root of it, where's it gonna go? Irrational. Okay. Okay, 3.895. Austin, where is that gonna go? Where does it go? It's a decimal that stops.
Rational.
Good. So it's gonna go in rational. Okay. -11. It's negative. Okay. Cash. Integer. That's great. Okay. Now here we have a fraction. Emma, where does a fraction go? Yeah, so in this diagram, since it's in integer, it's like a Venn diagram. Now notice how it's also in a rational bubble. Okay.
Well, the E goes in, the rational one.
It does go in the rational one. Very good. Okay. Ooh, pi. Emma, you just answered the last one.
But I want to do it again.
Okay, Caesar. Pi, where does that one go? Which one? E irrational?
Yeah.
Okay, sometimes you guys aren't enunciating very well. Okay. 1.7 repeating. Kanaya.
Yeah, bro.
Austin.
Yes, it's a decimal that repeats. It's a rational. Beg. Oh, perfect. Emma is begging for the next one. Emma, square root of 196.
Integer. Wait, no,
What?
natural, it's natural, my bad.
Why? What's the square root of 196? Oh, it is 14. And 14 would belong in our natural numbers. And all the rest, okay?
Let me do it again, let me do it again, I'm just so good.
Square root of 0 is 0. Wes, where does that go? Whole. 0 goes in our whole numbers. Okay, negative, absolute value of negative 34 is the same as negative 34. Okay, Austin, that is now 10 minutes. Negative 34 would belong in integer. Okay, 27 over 9 is 3. So that would go under natural. Stop. Negative square root of 4 is the same thing as negative 2. I told you to skip K. Negative 2 is an integer. So this is your job for me. Page 10. 10. The whole thing.